So let's continue learning transformers. In last lecture, we saw the models, which is the step number 2 behind the pipeline. Now in this lecture, we will take a look at tokenizer. Recapping behind the pipeline, a end-to-end pipeline in transformers library is made up of tokenizer. A tokenizer is a function which maps a word to its numeric ID. Each unique word is mapped to a number. A model takes in number as an input and then does processing on it and outputs a number. And we understand words, not numbers. So in output processing, we take that number and convert it into the format we understand. So we start with word, which is taken by input or taken by tokenizer as input, which is converted to number which is taken as an input by model, and it also gives number. And that number which we process and then we show it to user. Three-step pipeline. Here, now let's take a look at tokenizer as a section. So, what is tokenizer? I already mentioned. Tokenizer is nothing but mapping of word to its unique numerical ID. Now, let's think about this for a minute. If I build a vocabulary or tokenizer on physics, it is going to have a lot of word related to specific physics as domain. What if it's not just physics, it's quantum physics? What if it is not quantum physics? What if it's, let's say, fluid mechanics? The words which are part of the vocabulary, they are going to change, right? So according to whatever is the knowledge, we need to map those words to numbers. So depending on what the data model was trained on, tokenizer for each model is different. This is what it is. We have mentioned that BERT and GPT are generally the roots of all kinds of architecture. That's why we always see BERT or GPT here. Okay. So I'm just initializing a simple, most basic tokenizer, saying transformers dot BERT tokenizer. And then I don't want that tokenizer as is. I want to get the tokenizer which has been built from, by the Google company and given for us to be used ready-made. And for that, I say from pre-trained. Always, whether I'm getting check tokenizer or model, it's the same process in Transformers library. So we do this and we get tokenizer. Okay. So tokenizer, as I already mentioned, it maps a word to its unique numeric ID. Take a look at the sentences I've chosen very carefully here. Good morning has two unique words. Hey has a single word. Bye bye has two but duplicate words. So here, when I convert them to number, the third one should contains two numbers, but they both should be same. This one should be different, and these two numbers should also be different. So tokenizer, when it works properly, should show us that behavior. Now let's see if it does that or not. So tokenizer, which we have instantiated here, tokenizer from Hugging Face is equal to, let's say, tokenizer. So I have downloaded this from internet, this tokenizer, and I'm just saving it into this variable also. So for this tokenizer, on this tokenizer, there are a few functions I can call. So function like tokenize. This is a method. So what it does, it takes string as an input and then it gives the mapping of those strings into numbers. So it also gives us the details of this method. Similarly, there is another method, convert tokens into IDs. So this method will convert the tokens and give us just numerical IDs. And then there is another method called as decode, which takes in numeric IDs as input and gives us back the words we started with. Words to numbers, numbers back to words. Tokenize, tokens to IDs, and decoding those IDs back into words. So if we execute this, we will see that good morning, when gets tokenized, good gets mapped to this. So let me, good has gotten mapped to this here, and morning has gotten mapped to this number here, the second one. They are too close together. Hmm. So this is the good and this is the morning. Okay. So good is 1363 and morning is 2106. So what I've done is I've done a very interesting thing here. If I execute this code, it kind of like prints everything in a code cell. I don't have to separately write print statement. Okay. So just assume this. Pay attention here. 1363 is good and 2106 is morning. I'm doing decoding all different permutation and combination of those two words. What do you think will happen? It should be permutation combination of words which say make good and morning. Let's see if that is true. Yes, it is true. Good, good, good morning, morning, good, morning, morning. So you see, tokens to numeric IDs is what we do. We convert tokens into numeric IDs, and those numbers is what we send to the model for processing. Okay. For model, it doesn't need them just as number, it also needs them as PyTorch tensors. So that's why this return tensors equal to PT is generally used, but otherwise we call tokenize, or we directly call this tokenizer function variable with the sentence to tokenize. It still works. This is tokenizer. Once we start with a basic numeric mapping, then we can pass it to the model, and that model can actually give us the embedding of that word. Let me show you how. So I've downloaded this thing here, tokenizer config and model. This model is a pre-trained model. Let me check. Ooh, interesting. Check. This model has something called as embeddings. I think if I say it should give me, oh, but object is not subscribable. Maybe is it 0? Maybe it's embedding. Yes. So when I say model dot embeddings, it kind of like gives me a something to whom I should be able to pass in a value to get its meaning. So we saw here a big model is made up of multiple things. It is made up of embeddings, it is made up of encoder, and then it is made up of pooler. So by taking just the embeddings, we can extract just the meaning part. We have converted to number. I just wanted to see if I could also convert it to meaning. So this is how we are progressively going from a numerical world to the world of meaning associated with the word. So I'm kind of like using this model, and now you can now think, go beyond just tokenizer as numerical mapping, but now think about the meaning which is captured in the vector. So for example, if I say word to find meaning of as physics and I pass it to tokenizer, what it will do is now for this model, entire meaning of the word physics, maybe even all the laws, is summarized in just 768 dimension. Is it possible to do that? It can understand some meaning, maybe a lot, but not all of it. 768 dimensions are not enough. What if instead of physics, I say love? Does it capture all the romantic movies, poems, poetry, all the work of art, all the paintings, all the music, every single novel, whatever has been, does it capture all of that? No, of course not. So embedding might capture a meaning of the word, but it is nowhere compared to the depth at which we as humans understand that meaning. So this embedding, which includes the meaning, is a good start, but it is not the end of quality of tokenizer. Okay. For a data scientist, we just start to capture a basic meaning in embedding, and then on top of that we keep refining it, keep improving, so that we can at least hope to capture even a tiny bit of actual complexity of words meaning. So we are very far from there. So don't get overconfident into thinking that data science has solved a lot of problems. No, whatever we can capture now is still a tiny bit of what will be captured in future. So we have a lot farther to go.